Okay, get your notes on articulations and we'll start this chapter. First thing we'll talk about is joints. So let me get my little finger out there. Joints, a place of contact between bones, allows bending of the body. The word arthro means joint, like arthritis is inflammation of the joints. An arthropod, pod means foot. Joint-footed, these are going to be things like crabs and insects that have an exoskeleton. Joints are tight-fitting and have little movement, or they could be loose-fitting joints and have flexible movement. So we'll talk about several types of joints. In your classification, number 1 is synarthrosis. Syn means together, arthrosis is a condition. So it means joint together, is what it means. Immovable joints, so they are immovable joints, tight-fitting, may be fibrous or cartilaginous. And we'll get some examples of those on the next slide. So they could be fibrous, which means have collagen fibers, or cartilaginous, which would have cartilage like possibly hyaline cartilage. Number 2, amphiarthrosis. Amphi means like two sides, so it's a two-sided joint. Like frogs are amphibians. Amphibians, in the water they breathe through their skin, and when they're on land they breathe through their lungs. So it's a two-sided joint, slightly movable joints, may be fibrous or cartilaginous. So we'll see that also. A third classification of joints is the diarthrosis. Di means two, and arthrosis, a joint again. Two joints, freely movable. These would be like synovial joints, like your knee and your shoulder, those types, elbow. So let's look at some of these classifications with some pictures. Number 1 is fibrous joints. The joint is held together by fibrous connective tissue, which is going to be collagen. There is no joint cavity. So there's no joint cavity. So I've given you 3 examples here, just like this picture. The first one is sutures. Sutures between the bones of the skull. They are immovable. I see it says joint held together by very short interconnecting fibers. And you look down here, it says dense fibrous connective tissue. That's collagen. It's holding these bones together. So it's going to be a suture. It's a type of a fibrous joint. The second one is a syndesmosis. Syn means together, and desmosis, remember, it means to bind. To bind. We had desmosis was one of the intercellular connections. It held the cells together. So it means, holds together, joint together. These are slightly movable. See, it says joint held together by ligament. Fibrous tissue can vary in length, but is longer than in sutures. So slightly movable. And here we have your tibia, your shin bone, and the next bone that parallels the outside of it. These bones form the inner and outer parts of the bump of your ankle. This is the inner bump on your ankle. It's called the medial malleolus. This is the lateral malleolus. But the bones are held together by a ligament here, a lot of collagen tissue. It's a syndesmosis, to bind together. It's being bound together by collagen. This is one example. I've given you several others. The bones in your forearm, they run parallel, and so there are ligaments that hold those two bones parallel to each other, so they can't separate. And then there are the roofs of your vertebrae. The roofs form the spines, and so the roofs will have a sheet of collagen between them, and those are another type of a syndesmosis. The third one is a gomphosis. Gomphosis. This is a peg and a socket type of a joint. There's little or no movement, so it's a type of a synarthrosis. So it's a tooth and a socket. And your tooth is held in this bony socket by these collagen fibers called periodontal ligaments. All these little bitty lines here that are holding that tooth in the socket, those are collagen fibers. And they're going from a bony socket to a bony covering of the root, which we'll learn what that's called later. It's called cementum, and that's what holds the tooth in the socket. So that's going to be little or no movement for your teeth in the socket. I had a nephew that got his front tooth knocked out, and a dentist in the gym washed his tooth out and stuck it back in his mouth. Well, it took, and he still has that tooth, because what happens whenever your body gets damaged? Doesn't it repair itself? Yes. These periodontal ligaments were broken, the tooth came out, the dentist stuck the tooth back in, and the scar tissue, collagen fibers, reformed and secured his tooth back in the socket. Cartilaginous joints. So number 2 is cartilaginous joints. The bones are held together by cartilage. There's no joint cavity on this type of a joint. So the first one is synchondrosis. It means together with cartilage condition. So the bones are held together with cartilage. The epiphyseal plate, the growth plate, is hyaline cartilage, and it's between the epiphysis and the diaphysis of this bone, and it enables them to grow. Remember, the epiphyseal plate or the growth plate adds bone to the shaft of the bone to make it grow longer. But this is a temporary joint. If you remember this cartilaginous joint, when you're leaving puberty, that's when your hormones are starting to be produced by your endocrine glands, and those hormones turn these growth plates into bone, so they ossify. The hormones cause these to ossify and you stop growing. So you need to get all your growing done while you're still in puberty, because once you start secreting hormones, this cartilaginous joint is only temporary. It becomes osseous. The costal cartilages, these right here, costal implies rib, is between the rib and the sternum, your breastbone in the middle of your chest. And these are permanent types of cartilaginous joints. So they connect the ribs to the sternum. It's a permanent cartilaginous joint. The third type is called a symphysis. Symphysis. Okay, it's a growth together. You see these discs here. Articulating bones are covered with hyaline cartilage, so these vertebrae have hyaline cartilage on them, and a thick compressible fibrocartilage pad. And that type of a situation is called a symphysis. So we have the pubic symphysis that we'll look at on the next slide, and we have the intervertebral discs here, which are examples of a symphysis. So let's look at slide 4. And we see again, here's the temporary synchondrosis, the epiphyseal plate that will ossify. Here's the costal cartilages. That's a permanent type of a synchondrosis together with cartilage. And here are some symphyses down here. There's your intervertebral disc again, the fibrocartilage pad, the symphysis there. And here's the pubic symphysis that holds your 2 coxal bones. Those are the bones of your pelvis here. Holds those together in the front. That's also fibrocartilage. Well, we have a synovial joint. This is number 3 in your notes. Synovial joint has a joint cavity. You can see this is a joint cavity. There's a space here between the bones. The ends of the bones are covered with hyaline cartilage. Remember, hyaline cartilage, where you can find it? It's on the ends of long bones. Hyaline cartilage covers the ends of long bones for articulation. These are highly movable joints due to articular cartilage and the ligaments. You can see that the example here is the shoulder. You know that your arm is very movable, forward, backwards, up, down in a circle. It's very articulate. So here's your articular capsule. That's your blank in your notes. Articular capsule. A fibrous connective tissue capsule whose parallel rows of fibers are continuous with the periosteum of the bone, so it's flexible and strong. Look at the periosteum covering this bone up here at the top, and you follow it down and it bridges the space between the 2 bones, and there it is back again on the bone below. So the periosteum bridges the gap between the bones, and that's going to be what's called the fibrous capsule. So we have the capsule includes the fibrous capsule, that's the periosteum that bridged the bones, so it's going to be collagenous. And the synovial membrane, this green lining here on the inside, is called the synovial membrane. And it's going to be the membrane we're going to talk about in a minute that secretes a fluid. So this type of a joint contains bundles of connective tissue called ligaments that we'll look at in just a minute. Okay. The synovial membrane that I was mentioning, the green inner lining of this articular capsule, the inner layer of the articular capsule composed of loose connective tissue and some adipose. It secretes a viscous fluid called synovial fluid, which coats the articulating surfaces, this cartilage, on both of the bones, and lessens the friction during movement of the joint. So you don't hear any rubbing when you bend your knees or your arms or your elbow, because that synovial fluid allows the two hyaline cartilage covered surfaces to slide past one another. The next thing in your notes is accessory ligaments. Accessory ligaments, and we're going to look at a joint in particular. We're going to look at the knee. So it says these ligaments give the knee medial lateral support as well as anterior posterior support and allow the knee to bend. So these are just some things about these accessory ligaments around the knee. And we're going to look at two types, ones that are outside of the articular capsule and some that are inside. So the first we'll look at are called the extracapsular ligaments. They're on the outside of the capsule. And so on your notes, extracapsular ligaments outside the articular capsule, they give medial lateral support to the joint. So here's your medial and lateral sides. This is the medial side. This is the inside bump on your ankle. This is the outside bump on your ankle. So, number one, the tibial collateral ligament or the medial collateral ligament, it could be called either one, keeps the upper portion of the leg femur from falling lateral. See, it's attached on the medial side, and so the femur can't go lateral. It can't fall off the lower leg. Well, let's look at the other side. The fibular collateral ligament or the lateral collateral ligament can be called either one of those because it's on the lateral side, and it's also on the side that the fibula is on. Keeps the upper portion of the leg, the femur, from falling medial. It can't fall medial because it's attached on that side. So these extracapsular ligaments on the medial and lateral side of the knee prevent medial lateral movement of the femur and the tibia. They're pretty much stabilized. They hold each other and prevent each other from moving medial or lateral. Well, there's some that are inside the capsule also, and they're called the intracapsular ligaments. They're on the inside of the knee. So inside the capsule, they give anterior posterior support to the joint. Your knee doesn't, move anterior posterior either. So let's see why. Number one is called the anterior cruciate ligament. Anterior cruciate ligaments. They're attached to the intercondylar eminence of the tibia. Well, over here, showing the anterior cruciate, this is the tibia, the very top of your shin bone, and there are two little projections called intercondylar eminence. Little projections. This is the medial one, and that's the lateral one. So looking at the reading again, they're attached to the intercondylar eminence of the tibia and the lateral condyle of the femur. So it's going to be the medial intercondylar eminence of the tibia and the lateral condyle of the femur. All right, we'll see this one's going on here on this drawing, anterior to posterior. And here you can see that it's crossing over. They're going to cross over each other. And cruciate means cross, like crossover. They're going to cross each other. So look what it does. The anterior cruciate, look where it is in this picture on the left, prevents the femur from falling posterior. It's attached. It can't fall back. And the tibia from going anterior. It's attached. It can't fall forward. So that is doing anterior posterior support. That's one of them. But there's a second one. This darker one is called the posterior cruciate. and I have it over here. The posterior cruciate is attached to the lateral intercondylar eminence of the tibia and the medial condyle of the femur. And so if you look at the picture over here, the side shot keeps the femur from falling anterior and the tibia from falling posterior. So the cruciate ligaments, the anterior cruciate and the posterior cruciate, keep the knee basically stable, prevents the femur from falling anterior or posterior, and the tibia from going anterior or posterior. Cruciate implies crossing over, like a cross. Now the meniscus. Well, let's look at the cruciates again because I have it marked on my notes. Here's the anterior cruciate, there's the posterior cruciate. So that's for your anterior-posterior stabilizing of the knee. Here's your fibular, remember, or lateral collateral ligament. And here's your medial or tibial collateral ligament here. So that's your medial lateral stabilization. Well, between the femur and the tibia, there's this fibrocartilage pad called the meniscus. So you have meniscus, a fibrocartilage pad which allows the joint to fit tightly. It fills in the space between this tibia, your shin bone, and the femur, your upper leg bone. Fills in that space. And we have a number 1 and a number 2. So let's look at the two parts of the meniscus. You can see there are two parts, medial and lateral. So let's look at the next slide. And number 1 is the medial meniscus. Medial meniscus is on the medial side, and it says C-shaped. And if you look at the basic shape, it is somewhat of a C-shaped part of this meniscus. It's a fibrocartilage, and it's somewhat C-shaped, semicircular. And you look at the other side, it's called the lateral meniscus, because it's on the lateral side, and it's somewhat ring-shaped. It's more circular than the one on the medial side, so it's described as being ring-shaped. But that's the lateral meniscus. There is another ligament that goes across the front of the knee. It's called the transverse ligament of the knee. Connects the two meniscus on their anterior surface to keep them from going laterally. So it keeps them from separating. So it's a strengthening ligament on the front part. I drew a picture down here, and we'll see another one too, but this is like if the tibia is down here at the bottom, and this is the meniscus sitting on top. This is sitting on top here. This is a bird's eye shot. This is like from the front. These femurs of the condyles of the femur are going to be going down into these well-shaped surfaces that the meniscus has. They're concave. They dish in here and dish in here for these two rounded knuckle-like condyles to articulate in. So the upper surfaces of the meniscus are smooth and concave to accept the condyles of the femur, and the lower surface of the meniscus is somewhat flat and smooth to rest on top of the tibia. So when we look at this picture, again we can see how that is. The top of the tibia is kind of flat, and so this is sitting flat on top of the tibia. These have raised edges on the side, and they're dished out in the middle here to accept these knuckle-like rounded surfaces here called condyles. They can slide in the two little meniscus here. Now bursa is also on this page. These are sac-like structures. They're the green structures here, lined with synovial membrane. There's that word again, making synovial fluid. The fluid is similar to synovial fluid. They're located under tendons and muscles and between muscles. They allow the skin to move, less friction where skin rubs over the bone. They cushion the movement. So where you have tissues sliding past one another, you're going to have these bursa. And you've heard of bursitis, an inflammation of the bursa. You can have bursitis in your knee. You could have it in your shoulder, your wrist, your ankle. Just some examples of where you can have bursitis, but you have lots of bursa. You can look those up on the internet and just see that there are a lot more than I've got on this picture here. Now, when you turn your page, so there are some things that will in your movement that will restrict your movement. So the following limit the range of movement of a joint. These are just a couple of things here. The first one is apposition of soft parts. That's where they touch each other. Bending of the arm at the elbow, the forearm, this muscle of the forearm, presses against the anterior surface of the arm. Okay, pressing there. That'll restrict the degree you can bend your arm. The same thing for your leg. Tension of the ligaments. We just looked over tense ligaments that stabilize the knee, the collaterals and the cruciates. These ligaments restrict the limitation of movement. An example would be the collaterals and cruciates of the knee, but you can still bend the knee. Muscle tension. This may prevent the full movement of a joint by causing an opposing force against the movement of the joint. Now this person, this is the only picture I could find. If they're standing up and they try to lift their leg, that's about how high you could lift your leg just straight out. But if you bend your leg, you see that you can lift it higher. So you're releasing muscle tension when you bend your leg. Here's some joint replacements. Here's a total hip here, where you're not only cutting off the head and the neck of the femur, the top part of the femur, you're replacing it with a stainless steel or a special titanium type of a head and the neck, and the socket that it goes into called the acetabulum. That's what you call a total hip replacement. So that's your first one there. The head and neck of the femur are removed and replaced with a stainless steel ball and a plastic acetabulum. That's a total hip. A total knee. Now, I haven't seen one of these. This is the picture I found, but this is a pretty drastic total knee because it's covering part of the femur, and then this bottom part has a shaft that goes down into the tibia. And that's your knee there. It does bend. Here's one over here that's less drastic. They just took the meniscus out, and you have a Teflon meniscus, and this is a plate here that it attaches to, and then it has a shaft that goes down into the tibia. And up here the femur had the condyles removed, and now you have some stainless steel condyles that will articulate with this new meniscus. Here is a shoulder joint replacement, which is very similar to the hip because they're both ball and socket. It's just that this one is more shallow, ball and socket. And then some other joints like these plastics, I think they're plastics for your fingers. Plastic joints are used to replace joints in the fingers and toes due to arthritis. The tendons are not touched, so the joints are as good as new because the tendons are going from muscles in your forearm to your fingers on top and on bottom to open your hand and to close your hand. And these are just the joints right here that can be replaced. Getting into some movements, there are a lot of little different types of movements that we can talk about. The first one is gliding. This is your first one up here at the top. Gliding. The articular surfaces are small and flat. There is back and forth movement and side to side movement. No rotation. So you can go back and forth or up and down, but no rotation. It's the simplest movement that can occur at a joint. And I gave you several examples of gliding movements. Between the carpals, that's your wrist bones, and between your tarsals, that's your ankle bones. Between the heads and tubercles of ribs with the vertebrae, those are fascists, very little movement. Between the superior and inferior articular surfaces of the vertebrae, we'll see those when we look at the thoracic vertebrae in particular. Between the sternum, the bone in the front of your chest, and the clavicle, your collarbone, and between the scapula on your back and your clavicle, your collarbone. So those are types of gliding movements. Angular movements, number 2, movements which increase or decrease the angle between bones. Now, this is not the best flexion you could get. Just flexing your arm when you flex your muscle. This is a type of a flexion which is going up, but flexing your arm when your elbow bends, that's a flexion. Decrease the angle between the surfaces of articulating bones. So you go from your arm straight out, flat, 180, to 90 degrees or less when you flex your arm. So the examples I gave you were the the elbow, knee, toes, head, and fingers. You can flex all of those. Extend, and you see that she's flexing her knee here. That's a good flexion. You can do the same thing with your arm, though, at the elbow. Extension would be just the opposite of flexion, an increase in the angle between the surfaces of articulating bones. So you see they did do the leg down here where she's straightening her leg out. That's extending the leg. If your arm was flexed and you straighten it out, that would be extending your arm also. Opening your hand, that's your fingers. Your toes can be open too, or you can curl them for flexing or let them come out like you're walking for extension. Dorsiflexion. This would be like in your foot, the hand in your foot. Flexion of the hand at the wrist, like someone would say, talk to the hand, or the foot at the ankle, like you see here, lifting the foot at the ankle. Anatomically, the foot is already flexed. And then plantar flexion is like if you're tapping your toe, so you extend your foot to then step on something on the ground. Plantar flexion. Plantar implies sole, extension of the ankle. Now you look at this top picture here, you can see how she's flexing her head at the neck. So when you look down, you're flexing. When you raise your head back up to look straight ahead, that's extension. And when you look up at the sky, that's hyperextension of your neck. So hyperextension, an extension of a joint beyond the anatomical position. You can see on the far left here, she's hyperextending her back. She's leaning back. So she's hyperextending her back. Here is a movement called abduction, lifting the arm out to the side or the leg out to the side. Abduction. It means away from. AB means away from, like when someone is abducted, they're taken away. So look at the movement of a bone away from the midline of the body. And I gave you examples. Arm out to the side of the body like she's doing now. Spreading the fingers and toes. Those are abductions. And leg out to the side of the body. If she got her leg and moved it out here to the side, that would be an abduction. Adduction, a D-U-C-T-I-O-N. Ad means toward. So movement of a part toward the midline of the body. So her arm coming back down to her side, or her leg coming back down to stand on. Those are examples of adduction, toward the midline. So I have return the arm to your side, return leg to plant the sole of the foot on the ground. Those would be good examples. Your next one in your notes is circumduction. There it is. She's transcribing a circle here. The distal end of a bone is the movement of the distal end of a bone in a circle, while the proximal end remains somewhat stable. You can do that with your arm and your leg because both of those are ball and socket joints. Look at the, it says movement transcribes or describes a cone of 360 degrees. You know, she could make a real wide circle also. Look at what it involves. Flexion, abduction, adduction, extension, and rotation, all from that one movement. Let's look at inversion. Inversion, movement of the sole of the foot inward at the ankle. Sometimes when you've been standing for a while talking to somebody, you'll kind of play with your feet, and you tend to rock your foot to where your sole goes medial. That's an inversion. You could also stand there and tilt your sole of your foot out. So eversion is movement of the sole of the foot outward at the ankle. Well, another pair of opposites. Protraction is where you move, says forward movement on a plane parallel to the ground. So the mandible forward, that's your jaw, when you jut your jaw forward, or if you kind of pull your shoulders in the front, pull them forward, like you're going to hug somebody, your clavicle, your collarbone, does a protraction, it moves forward. Now the opposite, number 9, is retraction. Movement of a protracted part backward on a plane parallel to the ground. So she's pulling her jaw back. And if you push your chest out and your arms go back, That's protraction of your clavicle. It moves backwards. Number 10, supination. Supination, movement of the forearm in which the palm of the hand is turned anterior or superior, palm up. So movement of the forearm where your palm is directed up. That's supination. And pronation is just the opposite. Movement of the flexed forearm in which the palm of the hand is turned posterior or down, palm down. One way to keep those separate is what I did when I was learning this was supination. Sounds like soup line, supine, soup line. And so if you're in a soup line, your palm is turned up holding your bowl. So supination is like palm up holding your soup bowl in the soup line. If that works for you, good. If it doesn't, I'm sorry. Number 12, elevation. Movement on which part of the body moves upward, like closing the mouth. And you can see that she's closing her mouth. Mandible, her jaw went up. And the opposite is depression. Depression of the mandible, movement in which part of the body moves downward. Opens the mouth like when you see your test. Yeah. Let's look at some more examples here. Structural classification of synovial joints, and gliding is one. They call it a plane joint here. It's a gliding joint. Articular surfaces are small and flat. They're back and forth and side to side movement. No rotation, just back and forth and side to side. You have your hinge joint. It's like your elbow. The concave surface of one bone. Concave is where it shallows. Fits into the convex surface, it bows out of another bone. Allows movement in only one axis at right angles to the bones. So you can only move your arm one direction when you flex your arm. It's pretty much the same thing with your knee and your fingers. Now a pivot at the very top here, a rounded, pointed, or conical surface of one bone articulates within a ring formed by another bone, or partially by another bone or by a ligament. This is an example of your first and second cervical vertebrae in your neck is one example. The first one is called the atlas, named after the Greek mythology guy who holds the world on his shoulders. That's what this one would be, the first cervical vertebrae. And the axis is the second one, which they've only shown part of what it would be, but it has a tooth-like structure called the dens that sticks up in this loop or ring that's formed by the first cervical vertebra. This is how you do the no movement, how you twist your head. It pivots around the dens here. So that was one of your examples, the joint between your atlas and your axis. And then there's one on the proximal ends of the radius and ulna, which they're not showing here, but it's right here between these two long bones right there. You know, you can turn your forearm over and only one of the bones moves. It's the one on your thumb side. Ellipsoidal, they're calling it a condyloid joint on this one. It's an ellipsoidal joint. The oval surface or oval-shaped condyle of one bone fits into an elliptical cavity of another bone. So the cavity is on this top one and the condyle is on the bottom one here. It permits side-to-side and back-and-forth movements. It's biaxial between the radius, that's one of your forearm, on your thumb side, bones, and the carpals, your wrist bones. Next one is a saddle joint. A saddle joint. And it's just like getting two saddles and putting the seats together. The articulating surfaces are concave in one direction, like the dish out where you sit, and convex in the other. Goes over. So you have concave on this one and convex on both sides of the saddle. So that's a saddle joint. The example between the trapezium and metacarpal of the thumb, we'll have to look at those when you get to the bones. It may not be that obvious an image, but that's what that is. It's a saddle joint. And then the ball and socket. They could have shown the shoulder, or like they show here, the hip. Ball and socket joint. A ball-like structure of one bone fits into a cup-like depression of another bone. Movements are triaxial, 3 planes. They can do flexion extension, abduction adduction, and rotation. And so that's the one that you did the circumduction with, the ball and socket joints. And that is the end of this lecture for articulations.